Yeah. Turn me up.
Hi, good evening, students. Good evening.
Good evening, sir.
Evening, sir.
All right, everybody's okay?
Good evening, sir.
Good evening to you. Good evening, everyone. All right, welcome back to another session again. Another week. There's not much announcement. Did I announce to you when is your next assessment date? I don't think I did. The next assessment date is scheduled for November the 14th. Okay. You receive a request to record. I guess somebody wants to record the class. Okay. All right, right. So so your next assessment date is scheduled for the 14th. Should there be any changes, then I will let you know a week in advance. But for now, it's set for the 14th. All right, and then I'll let you know what is coming on the test, what on the assessment, what you should prepare for. Okay, and also just as a reminder that the SBA topics are already in the groups. So starting as of next week, Tuesday, I'll be pulling up samples of SB's introduction, and then I'll be also walking you through how exactly an a math SBA introduction is supposed to be written, right? What are the things that needs to be in there, right? There's a lot of misunderstanding when it comes to writing an introduction. I've seen some introductions that are very, they don't follow the criteria, right? They're just like the regular SBAs, research papers where you introduce yourself or you thank the teacher. And there's always that little mix up between acknowledgement and introduction. So in next week Tuesday's class, I will be pulling up a document on screen that will show you the requirements for the SBA. And we're going to be going through it stage by stage. So every week we go through a different section of the SBA. Remember that once you've completed the required section of the SBA for that particular week, it is best if you submit it physically, unless you live overseas. Like I know my students who are living overseas now. We're not living, but they're there overseas now. Then that's when I can accept it through email and so forth. But if you're physically here in Jamaica, right, then, or you're in Manchester, then obviously I would prefer to have my hands written on the paper and to point out where and where you need to fix if necessary. All right. All right, that's the only announcement I have for you for this session. All right, so let us just try to wrap up this week. Yes, go ahead, question.
For the exam, which is November the 14th, do we have to come in face to face to do the exam?
No, my online students, they do it right here on screen.
Okay, thank you, sir.
Yeah, you have an option. If you want to come in face to face, just let me know and you can do it, but you don't have to.
Okay, sir.
Got you. All right. So we don't have any questions. Today is Wednesday. Today is Thursday. And just off the top of my head, I think today is our measurement day. Is that so? Can we confirm?
Yes, sir.
Yes, sir.
Yeah. All right, dope. Nice. And then I'm assuming that we would have already gone through Heron's formula. We would have gone through the area of a right angle triangle. And we would have also gone through Heron's formula. We're going to do a recap as usual. Always doing a recap. So let's put up that on screen here for you. Alright, so this obviously would have been what we were doing last class, right? And for those who may have missed out on that class, Kevin, do me a favor now. Just forward the YouTube link so they can access it from the chat. Alright. So that lesson, I've not put it out as yet. It's not fully edited as yet. So I'll be releasing those over the course of the weekend. So what you're seeing here on screen has not been released as yet. As soon as it is, then you'll see the link being sent in the group for that. Okay, checking the document to see if I can find it. Not here. All right, that's where we were at. It's a little bit jumbled up though. All right, so, oh, wait, hold on. When did we do the triangulate? Somebody confirm with me because I'm not seeing the page.
Yes, sir. We
Yes,
did.
sir.
No, no, wait, disappeared gone. All right. So did we do? All right. So sure. Well, I'm just remembering what I posted. We did area of right angle triangle, how to find the area and how to find the area and how to find the side given the area. Did we do Heron's formula?
Yes, we did.
We did. Oh yes, and it was Miss Heaven that had wrote the question. Right, I remember that class. All right, so let's do a recap just to make certain that nobody is left out into the dark. So we have a triangle. Okay, let's do something like this then. Let's do this particular shape. Right, and then let's just do a second, guys. I'm trying to get the shape. All right, so I have that shape here on screen, and I'm gonna put some measurements on it. I'm gonna put this to be 11.3 centimeter. I'm gonna put this to be 5.5 centimeter. I'm gonna put this side over here to be 13 centimeter. I'm gonna put this side to be 7 centimeter. And I'm gonna put this side to be, let's put this to be 7. Okay, that's 5.5. So give me a sec. I think I need to lessen this side. Give me a second, guys. Let me get it right. It's 11 centimeter. So that would be 11 and 7. That's 18. 18 and 5. 23. All right, that should work. So that's 11 centimeter. All right, so the question then is going to be find the area of A, B, C, D, E. And this is A, this is B, this is C, this is D, and this is E. Shape, find the area of the whole entire shape put together. All right, and you're gonna encounter shapes like these on a regular. All right, so anybody, what is your thought process? Any suggestions from anybody? Anybody have any idea how we would start?
Formula first.
Go ahead, Miss. I didn't hear you.
It's a formula.
Yeah, but formula for what? How would you start? I mean, we know we're going to need a formula.
Write down the formula.
Yeah, but the formula for what? What exactly are you writing on the formula for?
Excuse me, sir.
Yes, go ahead. Screen is not showing.
Can you please accept my other device? I'm logging off from this.
Okay. You're going to do it now?
Yes, sir. They already said that they'd let the host know that I want to join.
Okay.
Okay, thank you.
All right, welcome. All right, so yeah, we're going to start by writing on a formula, but the formula for what exactly? Is it the formula for the area of a rectangle, a square, a triangle? What formula for what? I know that's the golden rule, but what formula for what are we writing down? Nobody? Yes.
So I will try to find the area of the rectangle first and then the area of the triangle.
Excellent. So let's start there. So we're going to find the area of the rectangle. So area of the rectangle. And what's the times width? Do we confirm?
Yes, sir.
So the length would be what?
11.3 centimeters.
That is correct. And the width would be?
5.5 centimeters.
I'm coming. 5.3. Guys, give me a second, okay? Hold on. Give me a second, guys. Miss Heaven, so you're seeing that you're gonna find the area of the rectangle, which is 11.3 times 5.5. I believe that was
62.15.
how much you got?
62.15.
Okay. Centimeters squared. All right, good. So we start there. That's good. So we already have the area of the rectangle. Then I believe you had mentioned as well that you're going to find the area of the triangle.
Yes, sir.
All right. So on that triangle, we are only seeing two sides, which means that we are short something. We don't have a base. We don't have a height. So it means that we don't really have a formula yet. So we need to improvise. How would we improvise to get a formula to be used? What would we do? What do you think we'll have to do?
Sir, since it's attached to the rectangle, the other side with the base would be 5.5.
That's correct. Very good. So since the triangle is attached to the rectangle and the opposite sides of a rectangle are equal, then it's safe to say that this side is also 5.5. And so therefore now that gives us a triangle with all three sides. Now, what's the formula that we use when we want to find the area of a triangle with all three sides?
Herrons formula, sir.
That is correct. All right, so Herrons formula has two parts. We need to find what is known as the S value. And I believe that the S value is what is called the semi-perimeter. So that is A plus B plus C all divided by 2. And that becomes 11 plus 7 plus 5.5 all divided by 2. All right, I believe when we work that out, we should end up with 23.5 divided by 2. And that should give us a rounded answer of 11.75. Can we confirm?
Yes, sir.
11.75. All right. All right, so now that we have 11.75, we're then going to move to the A section, which is A is equal to the square root of S bracket S minus A, S minus B, S minus C. All right, so by plugging in those values in their respective position, we know that S becomes the square root of 11.75, open bracket, 11.75, take away 5.5, no, take away 11, pardon me. Then we have 11.75 again, take away 7. And then we have 11.75 once again. Take away 5.5. All right, I'm assuming that some persons are already ahead of me. So that's going to be the square root of 11.75. All right, I'm assuming that you guys would have subtracted this already. So 11.75 minus 11 leave us with what? 0.75?
0.75.
Okay. All right, and then 11.75 minus 7, that's going to give us 4.75.
5.
And 11.75 minus 5.5, that's going to give us 6.5.
6.25.
Or 6.25. Yes, you are correct. You are correct. 6.25. All right, go ahead and process that product, please. 11.75 multiplied by 0.75 multiplied by 4.75 multiplied by 6.75. We should end up with the area being equal to the square root of, talk to me.
261.6.
261.62.
62.
And then go ahead and process the square root of that number.
$16.17.
16.17. Square centimeters. All right, but the question is not finished because that is only the area of the triangle. So we had already calculated the area of the rectangle and we just calculated the area of the triangle. So by adding them together, then our final answer is 62.15 plus 16.17, and that's equal to
78.32.
78.32. That's what I heard. Squared centimeters. All right. All right. So that's just basically the revision there, just combining one of what we learned the week before and what we learned last week, putting them together. And there's much more questions like these that are going to be made available for you. Okay. All right. I want to take a little pause, and before I go into tonight's lesson, on every November, I usually have what is called a practice with me session. Well, I have a practice with me class. Some persons call it extra class, but I feel like extra class is just like, it's not like I charge people money, which I am, but it's called what I practice with me. So it's a case where, as opposed to giving you practice questions or sending them to you, and of course, we're gonna have some people that will try it, and then some persons be like, boy, me can't do it, me can't manage. I want to practice. I want you to practice with me. So I do these practice with me sessions on a Sunday. Same place online, right? And I only charge persons like $300 for 2 hours of practice with me. So it's like I'm not really charging you, it's just that I'm just compensating myself for my time. I usually do this from a Sunday from 6 p.m. until 8 p.m. And so what I do is that I bring the resources, and they're going to be materials that are based on what we have been learning, but they are just questions that are not usually worked in the class. Analytical questions, critical thinking questions, worded problems. It's a mixture of everything that we've been doing so far. it's kind of like revision in a sense, but it's just that I'm practicing with you. All right. When as I'm going through the session tonight, and I pause and I give you a question to try, I'm going to post my details in the chat. And if you guys are interested, I'm not starting this Sunday though. I'm starting next week Sunday. So if you guys want to be a part of it, you can always make the payment weekly, or you can make it monthly. It's up to you, because there's only 1 month of November still, because December is like a holiday period, so nobody's not really going to come to any extra class per se. Maybe 1 or 2, but that's just about it.
So
But
can
for
we pay
November,
online?
yeah, it's going to be online, not face to
No,
face.
can we pay online?
Right, so I'm going to post my details in
Okay.
the chat.
Okay.
All right. I'm not sure. And I have all the bank accounts, but I'm just gonna post my 2 main bank accounts, which is Scotia and NCB. And if you guys are interested, you just DM me, let me know, and then you do what you do, and then we just send the link or we kickstart the mission next week Sunday. Okay. All right. So, all right. And if you're not interested or you can't manage it or whatever, it's understandable. But I just want to give you the opportunity to do some questions that is generally not something that we can do in the class because of the time constraint that we have. Okay. All right. So putting that out there, it's there for you to take advantage of. All right. So tonight's class should have been there already, but here we go. So far we've looked at 2 formulas for triangles. We've looked at area is equal to base multiplied by height divided by 2, and we have explained thoroughly that this formula is specifically for a triangle that has a height and a base. And we've also explained that a triangle can only have a height and a base simultaneously if there is a 90-degree angle in the diagram. If there is no 90-degree angle present, then it's possible to have a base, but there is not going to be a height. And so if you end up with a triangle that does not have a height or a base, then you have to move to the next formula, which is known as herrons, which is what we just recapped moments ago. All right. And so herrons formula, just to reiterate the formula, it is S is equal to A plus B plus C divided by 2. That's the first part. And once you've obtained the value for S, then you proceed to find A, which is the square root of S bracket S minus A, S minus B, S minus C. All right. All right. And the good news to summarize all of that is that these particular formulas are provided to you not just by me, but by the actual CSEC examiner. So when you look at the front of your exam paper on the formula sheet at the bottom, these formulas are right there staring at you. So which means that your only requirement here is to just be very mindful of which triangle do I use which formula in. If you can know which triangle, which formula is used in, then there's no way them can trick you. All right. But we're going to end up with a triangle now where we don't have any height, we don't have a base, and we don't have 3 sides. So then what if you're asked to find, watch this now, guys, find the area of triangle below, of the triangle below, of the triangle below. And this is what the triangle looks like. Boom, boom, boom. And let us just say I call this side 11.7 centimeter. And let us call this side, okay, so 11.7 centimeter. And let us just call this side over here And let's call this side over here 13.2 centimeter. And let us squeeze a little angle right in here. And we're going to call this angle, say, 84 degrees. So then, when you look at this triangle, so you're being asked to find the area of the triangle below, and the triangle that you're looking at, it actually has two sides, and it has an angle of 84. So we can't use Herrons' formula because Herrons' formula requires us to have all three sides. We don't have all three sides, and you cannot use your ruler and measure on paper because most likely they're going to tell you that the diagram is not drawn to scale. So by process of elimination, Herrons is out. And then now when you look at the diagram, there is no base, or there might be, maybe you want to call this the base, maybe, but there's no height. Remember, we just said that in order for a triangle to have a base and a height at the same time, there has to be the presence of a 90-degree angle. And by looking at that diagram, there is no 90-degree angle present. So then, Mr. Peart, you've given us two formulas. Is there a third one? Well, there is. There is a third formula. It's called your SINE formula. So it's A is equal to A multiplied by B multiplied by the SIN of the angle divided by 2. Don't get spooked. That formula is also provided to you on the formula sheet. So that's your third and final formula. And so this is the formula that we use to find the area of a triangle given two sides and what is known as its included angle. It has a specific name. It is called INCLUDED angle. It is called your included angle. So it can't just be any angle that is in the diagram. The angle that you're going to take the sine of, that angle has to be between the two sides, which means that I can draw you a diagram and say that this angle is 47 degrees. I can put this angle that this is 47 degrees. And then I ask you to find the area, which what I'm trying to do here is to test to see if you guys know which angle you're going to find the sine of. Now, we can't use the 47 degrees because the 47 degrees is not between the 11.7 and the 13.2. So therefore, this forces us then to have to use the 84. All right. So in this case, then it's a very simple calculation, nothing too difficult. The A and the B are the sides that are known, which is 11.7, and it's going to be also 13.2. And then on your calculator, ladies and gentlemen, if you have your calculator in front of you, there should be 3 buttons that are sitting adjacent to each other. One is sine, the other one is COS, that is cos, and the other one is tan. If you see it, just let me know. If you're using a phone as your calculator, there should also be the 3 buttons sitting beside each other. Sine, SIN, cos, COS, tan, TAN. Have you all located your signs, your buttons, your functions?
Yes, sir.
Is there anyone who might not have located that particular button? All right, so you should have it. All right. And just in case, I know we have some shy persons in the class, they're not going to talk none at all. So let's put it up on screen and make certain that they are very, very aware of what this thing looks like. All right, so there you have it, sine, cos, and tan. So we're looking for this one, sine. That's the one that we're looking for. All right. So if I go ahead then and I sine 84 degrees, then you should see that the answer for the sine of 84 is 0.994. Is there anyone else that's getting something other than 0.994? Please let me know. All right, assuming that everybody has the right answer then, the sine of 84, the sine 84, all divided by 2. So, can you help me now, guys? What is 11.7 multiplied by 3.2 multiplied by the sine of 84? I just want the answer at the top. Please don't type everything into the calculator at once, because you are going to get an incorrect answer. So what's the answer for the top?
53.56.
58.56 divided by 2. And our final answer is 29.28.
153.
153.
0.56. 0.59.
Hold on, wait. When you multiply 11 times 13 times sine 84, I heard somebody said 58.56. Did I hear wrong or right?
Sorry, you heard wrong. 153.5.
Oh, yes. Also, hold on, give me a sec. All right, I heard wrong. Sorry. So you said it's 153 point, how much?
59.
59. And when you divide that by 2, you're going to get
76.79
square centimeter. And that's it. You can see that. So evidently the calculation is not a very difficult one to do. You just times it, multiply it by sine 84, and then divide the answer by 2. Answer. That's it. That's really it. All right. We're
Excuse me,
doing
sir.
now. Yes, go ahead.
Could you please show us like how to type all of that into the calculator?
Sure. So we have run numbers by me again. It was 11 point.
11.7.
So 11.7 multiplied by
13.2.
13.2 multiplied by, you press sine and you press 84, and here it is. And you just divide it by 2 then, and here it is. Is that okay?
Yes, sir. Thank you.
You're welcome. Now again, you have to be very familiar with how your device is used, because there are some calculators that you guys have bought that requires you to put the function, then the number, while some calculators require you to put number, then the function. If you don't know how to use your tool, then you're going to have problems, ladies and gentlemen. So you need to get familiar, test it. If you have the calculator that allows the writing to come on the screen, then it's always the function, then the number. If you have a calculator where nothing is coming on the screen except the number, then it means you have to put the number first and then the function. All right, so just get used to your machine, that's it. It's no big deal, it's not a challenging question. It won't challenge you. The challenge in this question is identifying that this is the formula that is needed to solve this question. Okay. All right, I'm going to give you one to try. Okay, not going to be a challenging one. So we have this triangle here, and I'm going to put 32 degrees here. I'm going to put 17.4. I'm going to put this is 32 degrees, guys. 32, that's 32 degrees. I'm going to put 28 degrees right here. And I'm going to put 5.3 here. All right, so go ahead and 5.3 centimeter. So go ahead, guys, and find the area of the triangle that you're looking at. Find the area of that triangle. Go ahead.
Okay.
All right, who wants to jump on board? Anybody wants to jump on board? I want a new voice. I know Miss Barrett, I know Akilia, I know Miss Heaven. I want to hear a new voice. No Kevin already. Somebody else no want to try. No want to try and get it wrong, and then we know if you're right or wrong. Nobody wants to get any correction. Nobody wants to try.
Sir,
Yeah, that's when I got a new voice.
so it's Leona. First
Okay.
area
So area is equal to
A multiplied by B multiplied by sine theta. So the included angle is 28 based off
28. So what? So what? You know why we don't use 32? Because it's not between the two sides. Yes.
7.4 multiplied by 5.3 multiplied by sine 28
Very good. Divided by 2.
divided by 2. That would be 43.29 divided by 2, which would be
Answer?
21.645 or 21.65.
21.6. Okay. All right. That's it. Wasn't a challenging question.
64. It was
Sorry,
Or
that's
6.
21.64.
The 4 doesn't affect the 6. It's 21.6. That's fine. All right. So see, not a very challenging question at all. Not a very challenging question at all. All right.
Sir,
Good.
how you know when you use the 28 over the 32?
The angle has to be between the two sides
Okay.
at all times. So no matter which angle there I might put to throw you off, the angles have to be between the two sides.
Okay,
See?
sir.
Kavan, I'm going to send you something in your chat, and you just post it in the chat from here, in your personal DM. All right, now, majority of the time, it's very rare that you're going to get to use this formula as you're looking at it now, just by a blank diagram like that. Most of the time, I find this formula, when I say most of the time, not all the time, because it does come up, but most of the times I find myself doing questions. And when I have to be doing this formula, most times the triangle is always stuck in a circle. It's always in a circle. But because we haven't reached a circle as yet, I can't apply that concept to you as yet. So we're going to take a pause off the triangle. That's the end of triangles, really, when it comes to the area. So then we're going to move on now to what is known as the trapezium and the parallelogram. Those are the last two shapes that we're going to focus on for area for now. I'm going to hold on to the circle for a bit, because there's another topic that I want to touch base on, not tonight. It's called consumer arithmetic. And it's a topic that I want to go on to before the year finish. Okay? So we're going to pause on area after tonight's class, and then next week we're going to touch base on consumer arithmetic. When we complete that, we'll come back to area. So you'll have some time to process all those formulas that we've learned so far. Okay? So it is now 5. Okay, so we have 35 minutes. Let's see what we can learn in this 35 minutes here. All right, so anybody has any idea of what a trapezium looks like? Because I feel like that's one of the biggest challenge. Persons don't know what the shape looks like. So if I were to draw the shape and say, find the area of the shape below. If you don't know what a trapezium looks like, then you won't even know that's the formula that you should use. So anybody has any idea? Maybe you've seen a particular shape somewhere on an object. Where do you think you might have seen the shape of a trapezium before? Anybody?
Paper.
I didn't hear that. Go ahead.
Yes, I once in a math class, and I thought it was on the paper 2 for maths also.
Well, yeah, but I would want to know what it looks like. Do you have an idea? Can you tell me how to draw it? Do you have, like, maybe you could say, like, so it looks like a gas fan, or it looks like a cupboard, or it looks like a door, or do you have a particular object that you could say that it looks like it?
It looks like your pool table, sir.
Oh, well, the pool table is a rectangle, but I appreciate your effort, Shireen. Thank you. But the pool table is a rectangle.
It isn't a flat. The trapezium is a flat surface, right, sir?
Yeah, it's flat. It's a four-sided figure. It's four-sided, but so is a rectangle, so is a square.
It's incomplete or deformed rectangle. No.
Who said deform? You're the second student we used to look like, say deform.
It has parallel.
Come again?
Parallel sides.
Parallel sides. So parallel sides, you can go this way and this way now. You can go that way and that way. All right, so question. All right, so okay, go ahead. I'm listening.
No, I can go ahead, sir.
All right, so so I'm going to draw 3 shapes on the screen, and you're going to tell me which one you think is a trapezium, okay? And then you're going to tell me why you think it's a trapezium. So watch the shapes I'm going to draw now. Well, another, sorry, wait, guys. I don't know why that draws so bad. Well, I'm gonna get it. All right, so that's one shape. So that's 4 side. 1 side, 2 side, 3 side, 4 side. 1 side, 2 side, 3 side, 4 side. 1 side, 2 side, 3 side, 4 side. One side, 2 side, 3 side, 4 side.
So the last one
Which
is a
of,
trapezium.
which of the
The last one that you drew is a trapezium.
Okay, so that means
So that would be
so
D.
is everybody in agreement with the student? Do you think that D is the trapezium?
Yes, sir.
Anybody think C is the trapezium? Anybody? No? Everybody is in agreement that, let me see the chat. I mean, we're not answering in the chat, I'm not see. As I've seen messages coming in here. Let me see. Let me see. Oh no, there's not much chat. Okay, so Kiana said B is the trapezium. So everybody agrees it's D? Miss Cherry, what do you think? A, B, C, or D? You have to can't guess me. You can't say me none. You must can't guess. A, B, C, or D. I need some answers in the chat. The chat kind of dead.
Sir, I'm gonna be very honest with you and fall asleep.
Did what?
Fall asleep. I'm up
You
from
shouldn't
3
tell me
o'clock.
that. You shouldn't tell me that. Kiana says D. Shani says D. Kimona says D. Isis, Miss Isis, Mr. or Miss Isis says D. Leana says D. Latisha says B. D. Come on, D a win. D is winning, man. All right. We're not pressure nobody.
If you will come at your extra class then.
That now gonna help you. The extra class then has advanced concepts. That now gonna help you. Anyway, so all right, so the D, I agree, guys. D. All right. So for me, I think like what I learned way back then is that a trapezium looks like a car door. Well, the window of a car door. So anytime I don't remember what a trapezium looks like, I just remember the car door, and then automatically I know what the trapezium looks like.
Sir, the
Yes,
reason
go
why I
ahead.
said it was this one, was because every time I go draw it, I always I think of a rectangle, but then I say, oh, we can just play with the rectangle shape to get one trapezium. So that I can't really describe it in words, but if you
Right.
give me
I get you.
I
I get you. So yeah. So pretty much then, the trapezium is really like a partial rectangle. So you have one long side here. You have a vertical side here. Well, let me draw it better. So you have a long side here. You have a vertical side here. You have a long side here. Wait, I think one of the sides, I think the bottom piece is a little bit longer, and then you have a slant side. Oops. And then you have a slant side. Okay. So pretty much what we're saying then is that we're saying that this side is parallel. Careful now, guys. Parallel does not mean equal. All right. I have students that thinks that they are the same. So when something is equal, they have the same measurement. When something is parallel, they're traveling in the same direction. Or we could say that they're traveling in opposite direction as well. All right. So a trapezium has what is called a pair of parallel sides, which as us as mathematicians, we label one of the parallel sides A and we label the other one B. All right. And then the trapezium has also what is known as 290-degree angle. So boom, right here, so, and right here, so. And then we know so it has what is known as a perpendicular height, which is H, right here, so. All right. So the A and the B are, so normally we can identify the A and the B based on where the arrows are. And the H is always the side that is vertical. I'm gonna have to be careful when I say that, because if I change the orientation, the height can be at the bottom, the height can be at the side, the height can be at the top. But the height can easily be identified by the 290-degree angle. So wherever the 90-degree angles are, the 90-degree angles are, then that's where the height is. this slant side here, unless I am definitely trying to overlap some other topic with it, this slant side never comes into play, especially when it comes to the area of the trapezium. It never comes into play. All right. So then watch. Here's what my biggest fear is when it comes to students that are doing crash course mathematics. When they're doing crash course mathematics, a teacher will draw the diagram looking like this. And then on the exam or on the test, the teacher draws the diagram look like this. And then the student will wonder what kind of shape that. And then now when you ask them to identify A and B, them just pick any side for A and any side for B. So pay attention, guys. This is the parallel side. So anyway, so when you look at the diagram and you see the two arrows, they're not going to be that big, obviously. And then you see the 90-degree angle, because you have to see those, you have to see the arrow. Then can't tell it's a trapezium without the arrow being there and the 90 degrees being there. So I've changed the orientation of the diagram. So right now we can safely say that because the arrows are at the side and the side, we can say that this is A and this is B. And then remember that we just said that the slant side does not come into play at all, and the height is going to be at the top. All right. So that's my biggest fear. I feel like maybe it's my fear and it's not yours. Maybe you're good at it. Maybe you can identify it. I don't know. All right. But for me, I think the safest way is to identify A and B, and then automatically you will find H. And remember that A and B are located on the arrows. So you might ask, sir, what if they don't show me the arrow? They have to. If the arrow is not there, it's not a trapezium. It has to be there. Or if it's not there, they're going to write it in words and say the diagram below is the shape of a trapezium. So you're going to either see the actual word, trapezium, or you're going to see indicators that will allow you to make the mathematical assumption that it's a trapezium. Yes, Kevin, I know. I'm not putting it there. I haven't sorted that out as yet. So I'm just using the main ones. Okay? But you can go ahead and put it in the chat. All right. Good news again. I don't know. CSEC seems to just like to give you the measurement formulas. I've heard students say that the formulas on the exam paper, Mr. Pierre, they are useless. They give us formulas, but the questions that are on the exam paper, them formulas, they don't have no use. Them have use. It's just that you guys perhaps don't pick up that these formulas needs to be used in this diagram. But for me particularly, when you observe the formulas that CXC provides to you, they are usually the formulas that are related to area. So you're not going to get any gradient formula, any length formula. You're not going to get any vectors formula or matrices formula. No, are mostly areas. I don't know why them do it like that. I don't know why them don't give you other aid in other formulas. But this particular topic here, the trapezium formula is there. The triangle formulas are there. The trigonometrical ratio formulas are there. And some other formulas, circle, are mostly measurement formulas. There's a quadratic, there's one algebra equation formula that's there as well. But that's really just about it. So I do recommend that the formulas that are provided to you by CSEC, the ones that them give to you, you should save the space in your brain to study formulas that are not provided. So them little ones you're like area for trapezium, then give it to you. Don't stress yourself about studying it. I really like for you to study it and know it, but for the most part, you just need to just remember the formula. Remember to look at the front of the paper for the formula. So area is equal to small a plus small b in a bracket multiplied by h, and then you're going to divide the entire answer at the top by 2. All right, that is the area of the trapezium. Okay, and remember we said that the A and the B are located on the arrows. All right, fantastico. So therefore then, if I were to redraw another trapezium, I'm going to draw it another direction. I'm going to draw it this way instead. All right, boom. Draw it this way instead and this way. Okay. All right, and then I have 12 centimeter up here. And I perhaps have 16 centimeter here. And then I have 4 centimeter at the back. And I label it. Let's call it A, let's call it B, let's call it C, and let's call it D. And the instructions below states that you should find the area of A, B, C, D. Find the area of A, B, C, D. Well, like I said, if I draw a diagram on the paper and you can say, all right, this shape looks like a trapezium, then look at your formula sheet, scan through it, look for the formula for the area of a trapezium, transfer your formula to the solution sheet. A equals A plus B times H divided by 2. Can somebody tell me what is missing from my diagram? That's making what I'm saying flawed. What is it that's missing?
The arrows?
The arrow. If the arrow is not there, then all of what I've just said makes no sense. So there has to be an arrow, or there has to be some sort of given information that will therefore indicate to you that the diagram above is a trapezium. Because it could just be like a regular or irregular triangle. Sorry, an irregular an irregular quadrilateral. Could just be just a four-sided figure. Because if I draw a four-sided figure like boom, 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 pardon me. If I draw a four-sided figure like boom, boom, hold on guys. If I just get up and I say boom, 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 that shape don't have no formula. That shape don't have no formula. So therefore you can't find the area of that shape. They're not going to give you that and ask you. They're going to give you something else. So, good. All right. Somebody wants to finish up this question for me? Not Leanna, not Kavan, not Stacy, not Miss Helen. Leave on your voice. Not Damoy. As a matter of fact, Damoy, come. Long time in the area voice. Anyone I'm a new student want to come in? Yes, they are always on the front of the paper, Kiana. The ones that I'm talking about now.
Sir, can you go back to the slide, please?
Yeah, I'm going to go back to the slide. I'm trying to look for someone to pick on. Trying to look for someone to take set on.
Sir, can I try it?
Good. Oh, that's Miss Barrett?
Isis.
Oh, Miss Isis. All right, good. New student, like that. Go ahead, Miss Barrett. Miss Isis.
Okay. First of all, I'm gonna do my next step. So my
That's
first
okay.
of 4 centimeters. 2 centimeters.
Mr. Pa, I think your audio is out. Go ahead.
You hearing me now?
Yes, I'm hearing you clearly now.
Okay. 12 centimeters plus 16 centimeters times 4 centimeters. In the next line, I have 28 centimeters, which means I add
Wait,
12.
my 2 is missing. My 2 is missing.
Your what?
My 2, the divide by 2 is missing. Oh, you said it? I didn't hear?
Sir, you rush me thing.
Oh, sorry.
Yeah.
Sorry.
We're doing top part first before we
All right.
Yeah. So we have 28 centimeters times the 4. Now we have 120 centimeters. Oh, sorry, correction, 112.
Oh, right.
Yes. Now we're going to divide by the 2.
Awesome.
And we have 56 centimeters.
Squared centimeters.
Square centimeter. Yes, sir.
Thank you very much. Appreciate that. All right. So it's saying not too hard. Not hard. Once you know about A and B and H there, you just put the A, put the B, put the H, add in the bracket, multiply, then divide. Boom. Answer. Easy. Maths easy, not true? That's the truth, man. Maths is easy. Not thought the truth. It's not that bad. Like how some persons are painting the image that it is awful. It's not that bad. All right. All right. It's 8:14. So that's the idea behind the trapezium. Worst case scenario is that I draw a diagram. Okay, let's try this one. Let's try to mess up.
Sir, can I go back so I can finish right, please?
Finish that way?
Yes, sir.
All right, let's just try to end the class. Let's just try to mess up our own selves. Let's try to draw a diagram. I think somebody got cut off and is wanting to be let back into the meeting. Hold on. All right, let us see if we can come up with some sort of something now. Let's mess up what we've learned so far. So let us try to attach. Let us do this then. Let us do this then. I don't have the circle. It's a circle I would have wanted, but all right, that's fine. Let us do. Let us do this then. So we have a triangle over here. And let us do this over here. All right, nothing too tough. All right, I'm going to throw an angle in here, and I'm going to call this angle 38 degrees. I'm going to put this side to be let's call this 12.2 centimeter. Let us call this side 7.1 centimeter. All right. Let us therefore then go ahead and let us go ahead and say that this is 3.7 centimeter. And let us go ahead. In fact, let us call all of this side 12. Hold on. I'm going to try to mess you up, guys. I'm not smart enough, so I can't give them no easy question, you know. All right, so I'm going to just take my blue marker here. And from this edge to this edge, all the way up there, all of that is 12.2. All right. And then I'm going to put a stroke here, and I'm going to put a stroke right here. All right. And then I want to put, let's put 9.2 centimeter here. All right, so which of my student here would like to find the area of this particular shape? All right, let us call the shape a name. Let us give the shape a name. Let us call the shape P, Q, R, S, T. Which of my students? I want a new student to help me out. And if you give one new student a bus, find the area of P, Q. What is that letter? PQRST. So not Miss Isis, not Miss Heaven, not Kavan, not Liana, not Damoy. We need one new voice. Volunteer, I'm gonna pick on you. I'm scrolling, you know. Wait, you know, I haven't heard from none of the sisters though, apart from Shanika Heaven. But Sheena, you know, I don't know how Sheena's voice, you know. And Abigail seems to be new as well. Anybody? Am I gonna have to pick? Dip, any, mini, miny, mo? All right.
So I will try.
Who is that?
Abigail.
All right, Abigail. I appreciate you trying, my dear. Help me out. I need some help. How would I go about this?
Okay, sir. I think first we'll put I think it's called the equation. I think it's A equal A times B times sin. Is
That's
that correct, sir?
That is correct. It is correct.
Okay.
Sine theta divided by 2.
Yes, sir.
So what is it that you're doing for us here? Let the class know what are you finding?
Okay.
So the formula is right.
Yes,
but
yes,
what
sir.
exactly is this formula used to find? Is it the area of the whole shape you're trying to find?
Sir, really, I'm not sure.
Okay, you just want to, okay, all right. Anybody wants to pick up from her? Are you finished? Or you just want to just tell me what you're doing?
Yes, sir, I'm finished.
All right, so you start us off with a formula. All right, that's still fine. I respect that same way. Anybody wants to pick up? Not any of the students are called your names because they're going to answer it. I need somebody else. Latisha, you want to help us? She started off with the formula. Claude? Kian? Anybody can help? Pretty please.
Oh, you hearing me, sir?
Who am I talking to? Latisha?
Yes, sir.
All right, Latisha, talk to me.
All right. 7.1 times 9.2.
Aye. Me have to stop it there, so. So 7.1, me get the part the times, but the 9.2 is not on the triangle. 9.2 is on the trapezium.
Oh.
So the formula that Abigail gave us, you know, is
Oh,
actually the formula for the triangle right in here. So hold on, let me shade it. So that Abigail gave us the formula for find the area of this thing in here, so. And she gave us the right formula, but it only have one side. Can anybody else? One of my students then tell me what the other side is.
This 5.
How you no so the other side is 7.1? Why you think that the other side, what indicator is there for you to assume that it's 7.1 as well?
Equal sides.
Equal sides.
The sides are equal.
You see the two blue strokes them? It is telling you that if one side is 7.1, the other side with the blue stroke is also 7.1. So this side here so is 7.1 as well. Very good observation. So now, so Latisha, come now, finish up now. So 7.1 times
7.1
very good
times sin.
Well, listen, none of those sin my maths. It is sine. None of that things. I don't know why students always like to sin my subject. Sine. All right, sine of what?
Sine 38.
All right. I cannot look it up too much, so let me just hold on. Let me take time now. So 7.1 times 7.1 times the sine of 38, you said?
Yes, sir.
All right, divided by 2. All right, good. Talk to me, yes?
Good. I get 31.03 divided
For
by
everything at the top?
no, that's the first part. That's the
All right.
triangle.
So 7.1 times 7.1 times the sine of 38. Okay, so you get 31.03. All right.
Yes. Divide by 2.
31.03 divided by 2. And that's equal to?
15.5.
All right, very good. Abigail, see that now? So that's what the formula you gave us earlier. That formula that you gave us earlier was the formula to find the triangle. Okay, got that, Abby?
Yes, sir.
All right, good. Letitia, you want to finish it or you want to give somebody else?
All right. So we
What's the next thing you're going to do now?
A times B times H.
Is it A times B or A plus B?
A plus B times H.
So here is equal to A plus B times H divided by 2.
Yes, sir.
And what are you doing here? You're finding the area of the shape that is attached to the triangle. Are you finding this area? Is that what you're doing?
Yes, sir.
Okay. And how can you confirm that this is a trapezium?
Because of the shape.
All right, good. I think it's my fault. I really should have done this. I didn't do it, and I should. I keep forgetting. I need to put on the arrows. Yeah. Right. Because if I don't put on the arrow, it would mean that the formula that you gave me would have been flawed because it's not a trapezium. We're not sure. It has to be there. So that's my fault. But anyway, you are right, Letitia. It is the area of a trapezium. All right, proceed. All right, so what is your A and your B then?
All right. Then 9.2.
The 9.2, correct, plus?
5. Is it 5? I'm seeing 5. Or am I seeing wrong?
Maybe my handwriting bad. So you said 9.2, which is the one at the top, right?
Yes, sir.
Hold on, let me write it down. So that's 9.2.
I think it's 3.7.
All right. So remember, so we just said the A and the B are the ones that are on the arrow.
The arrows.
And the arrow is 9.2, but the side on the arrow is missing. The 3.7 is the height.
Yes,
so we have the A, but we don't know the B. Can anybody tell us how we would find the B?
I'm going to say divide it by 2 because
You said divide by 2?
yes, sir, because
go ahead, I'm listening.
Because both sides aren't the same. However, the number at the top should represent the number at the bottom. However, the line at the top is way larger than the line at the bottom. So that is
okay. All right, so you're making an assumption that the 9.2 at the top. Sorry, you're making an assumption that the line at the bottom, which is SR, is half of 9.2. Is that correct? Is that your assumption?
Okay.
All right. Well, we don't have any evidence to say that it is halves because on a trapezium, there is no rule or property that says that the one at the bottom or the top is half the one at the bottom or the top. We don't have that rule. So that would be a false assumption. So we have to try again. But I get that you see it, but it's not correct.
So you would minus the 12.2 from the 7.1.
All right, so watch your style now, guys, correctly, Anna. So if you notice that earlier when I had changed my mind, I said that the whole entire length from T to R is 12.2. Notice I draw the blue lines? But then in the initial stage, when you were finding the area of the triangle, somebody had stated that the two sides are equal. So we end up with that T to S being 7.1. So since we have the whole side to be 12.2, and we have a portion, not a half, but a part of it, which is 7.1, then SR, which is right here, is going to be 12.2 minus 7.1.
Oh, okay.
You see what going on, Latisha?
Yes, sir.
Yes, so you have to admit it. So you can't make any assumptions
Yes,
unless
sir.
you see something on the diagram that clearly indicates that something is equal to something.
Yes, sir.
Then you can't make the assumption based off visuals because the diagrams are not drawn to scale. All right, good. So that means 12.2 minus 7.1 is what?
5.1.
So you see now said the bottom piece this now is not half of 9.2.
Yes,
but
sir.
I respect the person who made that assumption because at least there's efforts being shown in the thought process. So 5.1. So let's get back to the question now, Latisha. So you said now the A is 9.2 and what is the B now?
9.2 or 5.1.
Very good. 5.1.
Plus 3.7.
Is it plus or times?
Oh, times.
All right, make sure you have that in a times. Times it to 3.7.
Yes, sir. So I'm gonna work it now.
All right, take your time and get there.
Plus 5.1.
I hope my quiet students who don't want to talk to me, I hope you guys are following the thought process. Come on, someone bright and no one talk, but I don't know why. But okay, that's fine. Divided by
9.2 plus 5.1 is equal to 14.3.
14.3
times
3.7
equal 52.9.
So that's equal to 52.9 divided by 2.
Yes, sir.
And that's equal to what?
26.5.
Thank you very much. Centimeters squared. So are we done? Is the whole entire question finished?
No, sir.
So how to wrap up all of this question now?
15.5 plus
Get the total right here.
26.5 is equal to
And then
42 centimeters square.
how much you got?
42 centimeters.
Flat?
Square.
Oh yeah, 42. So the answer is 42. Let's round it up. All right. 42, 40, 42, 41 point whatever. That's fine.
41.95.
41.95. 42 is also acceptable as well. All right. So 42 or 41.95. All right. So ladies and gentlemen, you are seeing clearly that we have some work to do. It's not a case where you're just going to get a trapezium and you just look at trapezium form now and a to go work. It's not going to be done like that. You're going to merge the diagrams, piece them on, and make some as the student said earlier in the class, some deformed shape. That's very funny to me though. Deformed shape. So you guys have to have critical thinking, which as I said, these things I can't really come to the class and teach you because in the class we only have enough time to go through the basic concept, give some notes, explain some examples, but in terms of the practical applications of the concept in some, what you want to call quote unquote advanced questions, then it requires us to do extra work. And I don't trust you guys to do it on your own. So I have to do it with you. So if you guys are interested in having that session, I am going to have it. If I even 10 people I have, I am going to work with those 10 people. It's not about the money. It's just about you being able to work on those critical thinking questions, worded questions. Okay? All right. So, ladies and gentlemen, go ahead. Question.
So you have a time frame set for the class? For the extra class?
6 o'clock in the evening until 8. If it kind of I want to set it late because I'm assuming that everybody will go to church, cook, eat them dinner, relax, and probably watch TV, and then probably can do some maths practice to start the week. So if you can vote in the group if you want to, and be like, okay, I prefer this time, and then I'll just work with the majority.
Sir, 5 to 7.
5 to 7.